Hi everyone, my name is Nikolai and today I'm gonna review this Ryobi compressor. We will talk good, bad and ugly about this. And don't get me wrong, it's an awesome compressor. I really like it and I could recommend it to anyone if it would have reliable construction, but unfortunately it's not. But first, let's review it. Compressor comes in this package, which show basic features. 160 psi, auto shut off, accessories included, a small nice box. Inside this box we will find, so it's not from this box, but we will find this paper that shows all variety of Ryobi tools. We can find this instruction manual, mostly warnings and stuff like that, and we can find another paper which again lists all the tools. And finally we have compressor itself. Compressor is really nice, it's really small, and we could compare it with my previous compressor, and if we check the size, it's really small. And even if we connect big battery 4 amps, it's still smaller than old one, which is nice. Another difference between old and new accessory storage. This one is outside. When it's connected to battery, you can lose it or something. And for this one, it's inside. When the battery is attached, it's basically hide it and there's no way to lose it. Compressor itself has 4 buttons, 1 button for turn on. It also has nice green backlight, probably because green is a Ryobi color. On top we have a PSI, our target PSI, and on the bottom we have our actual PSI. Power button we have to hold to turn it off. And we also have play and stop button, which is turn on compressor. And if we will hold it, and as soon as it's reached target PSI, it stops, and then it shows target PSI, and after some time it will switch to actual PSI, which is dropping because I hold my finger. And if we want to pump something to manually, we just can hold this button, and as soon as we release it, it stops pumping, which is really nice. So really nice small compressor, a lot of features. But why did I tell it's not reliable? And to understand that, we have to go inside this compressor. And by the way, I use this tool not because I like Ryobi, but because my screwdriver just doesn't fit all the way deep to unscrew it. T15, by the way. So let's open it. Oops. And this old construction that we have. One brushed motor, one fan. By the way, don't turn it on, otherwise if you catch something, all those blades will fly off. Don't ask me how I know. This is a PCB with all electronics that control everything. Looks like pressure sensor here, just mounted on PCB, and couple screws that hold this plastic holder. Probably something surface mount. Display buttons all here, and this main compressor. And as you can see, compressor is just plain plastic piston, which probably not such bad. Also plastic out for those hoses, spring clamps, which is nice, and this one is crimped clamps, which probably should hold also just fine. And But my main complaint about this compressor is here and here. And I will remove those C-clips to show you why. So, as you can see, there are no bearings at all. This one looks like brass bushing, just overmolded in a plastic piston. And this one is just metal by metal. So not a single bearing here. And what happens with this compressor? This bushing just wear off completely because of motion left and right, and it just destroyed it completely. And basically compressor started pumping less and less air, and it takes longer and longer to pump a tire, and finally it gave up and it should be fixed. And to prevent this, I will do this procedure on a brand new, never used Ryobi compressor now. So, what's the plan? And plan is simple: to install couple bearings, maybe like this or like this, installed in this gear, and couple other bearings like so, 4x8 by 3 mm MR48 in this piston. And after that, it should work fine. But by the way, I wouldn't use those bearings. I would use those bearings. Those are really nice. They look white because it's full ceramic bearings. They don't need lubrication. They don't afraid of heat, and they generally like better. But they also have disadvantage: if you drop it, it may shatter as glass plate. So be careful with those. But metal bearings should work just fine. And it's those just fancy. I just want to try how it turns out. As you can see, those bearings fit perfectly in this piston. So to remove these bushings, I decided not to try punch it because it may be overmolded like barrel shape or something, and it will not be possible to do so. I decided to use my milling machine. I use V-block to fix the piston, and I used broken 4 mm sand mill to align it more or less. It's probably doesn't need to be exactly precise. There's some tolerance in piston, so should be fine. So, and this is a result. As we can see, the bushing indeed barrel shape or something like that to not let it out. It looks like I drilled holes slightly off center anyway. Anyway, now we can try to feed bearings. Fit really nicely. 8 mm end mill did good job, so not sloppy, nothing like that. So basically piston is fixed. Now for this gear, to install this bearing, as you can see, it's not quite full metal here because it's resembled to crankshaft shape with counterbalance on opposite to piston side, but it should be fine. I'm pretty sure it should be fine. I'm wondering how many revolution it will make on a original bushing. Probably not so much. For installing bearing into this gear, I decided to use my CNC lathe to make a groove for it. The bearings would not fit in this hole, and it's intentional because first I have to set X on my lathe since there are no any end stops, and the easiest way to do it to make some hole and then measure it. Don't measure hole directly with calipers, it wouldn't work at all. At least it didn't work for me. Now I can see it's 1166/65, so I can adjust my X position and make a final cut to fit the bearing. By the way, my lathe in process of installing ball screw. As you can see, it's all 3D printed. It's even like 20% in fill. And pulley 3D printed. I didn't find 100 teeth pulley, 15 millimeters width for GT2 belt. And this one also all 3D printed, not very rigid, but still works. And this is how result looks like after turning. Small diameter, smaller in the center to prevent rubbing of inner race. And yeah, looks pretty good. Slightly bigger than it probably should be. And I also did slightly smaller on inside, so now I have to press fit it. Always use safety glasses, because if ceramic bearing will shatter, it probably may hit you in an eye, and it wouldn't be fun, I guarantee it. Nice. And now, when all bearings is installed, we can assemble it. So now it's assembled, all looks good, bearings good, and spin, no any problems. And now the question, will it still work after all my fixes? Let's have a look. Yep, looks like still works. And the final test, completely flat back tire, up to 65 psi. Let's go. And a battery died. Another battery. Looks like it remember 65 psi, even battery is removed. 33.5 now. And we're done. Now it works, and I hope it will work a long time. And the only question left, why Ryobi didn't make it in the first place? Oh, wait a minute. I guess I know why. Because it's planet obsolescence, I guess. You will use it, put a little bit, it will broke, and then you will go and buy another one and make Ryobi another 30 bucks or so. And that's basically it, because for me, install those bearings, not an easy task. But for Ryobi, I'm pretty sure it will cost them pennies to buy metal bearings and install it in the first place and make this a great product and long-lasting product. But they didn't. They decided to keep couple cents for themselves. So it's up to you. If you like it, you can buy it. If you can make it, fix it as I did, great. If not, then that's it for today. Thanks for watching and see you next time. Bye.